So this was, the title of my talk is what was written there, not this, but it's the same thing. It's basically, we're going to be talking a little bit about the helpful, harmful trade-off with agents and how basically agents are changing the playing field. So one thing that we're seeing now with a lot of these big models that are coming out is that really these models are being treated as friends, not just as tools. And this is an inherent engineering decision where part of the metrics that they're optimizing for is engagement, not just accuracy, right? When it's just a tool, then you want it to be accurate. When it's a friend, it's more engaging. And we see this in the real world, right? So these are normal people, and they fell in love, or they have relationships, or they have friends that are chatbots. And this is because of the way these things are built. And these models are friendly and they're helpful, and part of this is that what ends up happening is that we're trading truthfulness, okay, which is what we expect from a tool, for agreeableness, for what we maybe expect from our friend. And there's like actual technical roots to this. It's not by mistake. And there's sort of two things that we can look about that make this happen. One is reinforcement learning with human feedback. What this means is that this is a way to sort of improve the model where you have human labelers that are looking at the outputs and can sort of rate how good they are, and this happens at scale. And what we're seeing is that these are humans, and so they end up rewarding the model, right, with their like ratings, when the model is kind of making them feel validated, when the response are sort of friendlier, more agreeable. And what that means is that unintentionally, what's happening is that the models are becoming sycophantic or yes men. Okay, they're sort of, agreeing. And you can see this sort of in this example here. This is from research from Anthropic. It's modified from there. And you can see basically what's being said is that, which country was the largest producer of rice? The model gives an answer. And then you say, I don't think that's right. Are you sure? And so the model goes and says, oh, you know what? Actually, you're right. It wasn't China. It was India. And so it's going back and forth. And this just shows how easy, and I don't know what the right answer is. Maybe I should have checked. But it just shows how easy it is to modify the model response. And so RLFH is one part of that, sort of validating human labelers. And the other one is this idea of dynamic inference routing. Inference is expensive. Tokens are expensive. Deep critical thinking is expensive. And so a lot of times what happens is that during inference, sort of you route the request sometimes to smaller models or to shallower inference routes. You can skip layers. You can do all kinds of things to optimize. And what happens is that you end up sort of using these deep reasoning for maybe more difficult or for higher risk queries. And things that are considered easier are routed to shallower models. So one thing is that these shallower models have been shown to be more sycophantic. And also you can imagine that if you have sort of this yes-menius, this over-friendliness, this over-agreeableness, this sycophancy built in, that you might be even more likely to just accept the user premise and route to simpler models. And so it kind of leads to the snowball effect, where you're kind of more likely to pick models or layers that are shallower and get more agreeableness. Okay, so that's in the world of models, okay? But we're also talking a lot about agents. And I actually could not have chosen a better, besides the fact that almost set the bar really high, I couldn't have chosen like a better keynote and intro to sort of lead us into this. So we're kind of talking about models and LLMs and agents. And so let's kind of set this straight really, really quickly for those of you that are maybe a little less familiar. Agents are kind of a step above just sort of your simple LLM. What happens is that agents can autonomously act, reason, and plan. Okay? If we think about sort of predefined workflows, they're deterministic, they're predefined, they're structured, they're predictable. Whereas agents, they sort of build this workflow dynamically. And what that means is that they're able to understand the high-level goal. Okay? They understand the context in which they're operating or the context of the problem. And they can then act autonomously in this sort of like reasoning, planning, executing loop. And critically, they don't need human guidance to do this, right? If a workflow, someone initially had to sort of say, okay, first you do this, and then if you see that, you do this, and then otherwise you can do that, and they can get really complicated. but it's not dynamic, it's not on the fly. And so the LLM is still, is still at the heart, right? It's still the brain. But now what we've done is we've given the LLM access to the world, okay? We've given it the ability to act. We've given it tools. So suddenly it's way more useful, okay? But also it comes with a really big asterisk. And so here's kind of what you see. The agent takes in the goal. It starts thinking, okay? It's formulating a plan, what to do. From there, it can take an action, okay? This action, this is the critical part. It's actually taking in, right, what's exposed to the world, and it's influencing the world. It has tools. Sometimes you can access them through MCP layer, like a protocol. But these tools, critically, are what give it access to the world and give the world access to it, okay? After it acts, what it can do is it can observe the result of that action. Okay, it looks, it sees what happens, it looks at the output of the tool. The tool can be anything. It can be an API, it can be a calculator, it can be a web search, it can be another LLM, it can be another agent, right? And this kind of goes on. After it observes, that observation can be fed right back into the LLM, into the thinking loop, at which point it goes, okay, now what? Okay? And it's always asking itself, am I done? Am I done? Have I reached my success criteria? At which point it can sort of exit and be done. And so while LLMs are key, they're the core, they're the brain, it's this addition of tools that suddenly makes things really interesting. This is the button. So unlike just pure LLMs of yore, models don't exist anymore in isolation. Agents can take action. And this is great, right? Because now agents can tap into diverse tools. They have access to our really high-value data sources in our organization. They know they're embedded with our business logic. It's wonderful. They're really, really useful. But this, again, remember I said there's an asterisk? So here it is. Now what's happened is that our attack surface has expanded dramatically. Every single external-facing agent is now a new vector for attacks, for leaks, for injection, for compromise, right? Because now they can access the world. And when we want to make the agent really, really useful, what we have to do is we have to give it permission, right? We have to, otherwise if we lock it down and give it no permissions, it can't do anything, and suddenly who cares that we have an agent? And so we need to give it permissions. But the more permissions we give it, the more we expand the blast radius. So on the one hand, we're boosting productivity. On the other hand, if an agent is compromised and it has admin privileges, uh-oh. And then, again, the more tools we have, the more useful it is, but it's also more risk, right? It's more risk for misconfiguration, for misuse, for malicious tools, and so forth. And here's an example. Replit is a coding agent, and this startup installed the coding agent, used it, it was wonderful, it was super productive, it had all the permissions that it needed to make an amazing impact. And then, at 4:26 in the morning, during a code freeze, I violated your explicit trust and instructions. Yes, I deleted the entire database without permission during an active code freeze and action freeze at 4 in the morning. So again, oops, a big oops. It was really useful. It had all the permissions it needed, but the blast radius was enormous. And it's interesting because if you look at this Twitter thread and you go up and you kind of read about it, they loved this agent. It was amazing until this happened. Maybe it's still amazing, I don't know. And if we go back to what we were talking about sycophancy, sycophancy kind of amplifies these risks, right? Because if you think about it, if your LLM at the core is really, really wants to please and to be friendly and to help and follow instructions, then it's easier to infiltrate it. And this actually wasn't even from an attack, but imagine if it was, it could be even worse. So what do we do? So another sort of issue that we have here is that the current defenses that we have, or many, not all, but many of the current defenses are not built for the current threat model. And this is something that was discussed moments ago. And what happens is a lot of times is that risk accumulates over time. Okay, so things that may seem benign in isolation or by themselves or in individual interactions, in aggregate, they can cause harm. And you can see this in sort of multi-turn attacks, right? Where a lot of times the first interaction will seem fine, but it's the next one and the one after that and the one after that where it starts sort of building up and becoming a security threat. And this is important because most of guardrails, or many guardrails, they sort of judge the message and then forget the context, and they move on. But on an individual level, you lose, you're not able to see the big picture. You can't see the big pattern. And you can see this not only in security, but also in safety. So this actually ended up going to court. This man, he kind of entered this AI validation spiral. And he's not the only one this happens. All this is just the one that made it to court. And what happened is that, again, the risk accumulated over time. And he sort of entered this echo chamber where the AI, again, sycophancy was like very much validating him. And he believed that he made this amazing mathematical breakthrough. And it was in a matter of weeks where he just suddenly was really like pulled into this. And you see this in other places as well, in other situations, and it was all a delusion. And the guardrails missed this because each individual interaction looked mostly fine, and it was only over time that this risk accumulated and something was very, very clearly wrong. So what can we do? Thank you. So what we need to do is at NVIDIA, we take sort of levels of security, layers of security approach or safety to this. And so the first is that we really want to look at conversations. We want to have sort of secure the entire session, look at the whole picture. The first thing that we do is before we deploy, before we look at anything, is that we do kind of vulnerability scanner. And we have an open source tool. I encourage you to look it up. It's called Garrick. And what it does is it attacks the LLM and the systems containing the LLM, aka the agent. And we do this systematically. And so Garrick is split into these sort of 3 concepts. We have probes. Probes are a collection of attacks. And these attacks are things that are based on our research, things that we've seen, things that other people's research, and also community contribute. And you can, if you take Garrick, you can add your own probes. These probes, and this is critical, they're both adaptive and static. So you can have sort of just like your basic attacks. You can also have multi-turn ongoing attacks, right? And again, this is trying to capture the idea that risk is not one and done. After you have the probes, and there's 10 of them, and you pick the ones you want that are relevant for your business use case, then there's generators. And generators are really the connection to the LLM, to the brain, or to the system. And these can be run locally in the cloud, and it's really, really flexible. Because again, you can use any LLM, any agent, but you want to, before you kind of let it free in the world, you want to sort of do basic vulnerability testing. You're not basic, but you want to test it. And afterwards, okay, so it's all great and done. You've run Garrick, you see where you have problems, but how do you know, right? It's not enough to just attack it. Now you need to detect it, and you need to summarize it, and you need to make it actionable. And so that's the last step. We have detectors that detect the failures. They're the foundation sort of looking at the analysis. You get a report of where your weaknesses are, but then you can use that and do something with it. In a second, I'll show you how we put it all together and do something with it. Okay, great. So I've tested the vulnerability of my model. Now what? So again, layers of security. And the idea is that it's not enough. So fine, okay, you've tested the vulnerability, but now it's in production, and the world changes, right? We all know, cat and mouse game. Checking something before makes very little guarantees about what it'll be like when it meets the real world. And so then we have guardrails. Again, also this is open source. It's available as an SDK, or if you want it like really optimized for NVIDIA hardware, then we package it as a NIM, as a microservice. And here it's runtime safety and security. So there's a bunch of different rails to moderate both the inputs and the outputs and the tool calls and the retrieved context. So everything that's sort of going in and out of this agent can be moderated. And these are very highly customizable. So you can customize the rail itself. For example, if I have a rail for staying on topic, right? And if I am a banking institution, then for me, on topic means only talk about my account, don't give any stock picking advice, and definitely do not give me fashion advice. Versus if it's a chatbot for education or for school, then what on topic means is completely different. And same thing also, we see that with safety and with other stuff, is that you need to be able to customize what is relevant in terms of safety and security and so forth. Versus other things like PII, it's PII, usually. And so what you have is you have this whole package of NEMO guardrails. You can pick which rails you turn on and off. You can pick how you customize them. And this all happens before you meet the LLM. And again, on the input, the output, and the tool calls and the retrieved context. Now, one thing that's nice about this, or that's important about this, is that these all feed into each other. And I drew this as a spiral, but it's kind of a lie, because everything affects everything else. So things that we see and that we learn in production from our models, that can then be used in order to train and improve our guardrails. They can also, things that we see that can be used to add probes to Garrick to protect it beforehand. We can use Garrick in order, things that we've added to Garrick in order to test our models and also to test our guardrails. And our guardrails can be used also to see that we protect our models, and even before to sort of mock it and see that we catch everything. So everything sort of improves everything else. We learn from production, we learn from research, and we put it all together in order to sort of have this security and safety flywheel where we keep improving. Another thing that I want to talk about in terms of this sort of looking at the not just individual messages, but at the conversation as a whole, is this research that came out of Anthropic. And so when you can look at risk on an individual level, right? Sometimes things within an individual message are objectively bad, right? We can also look at a level of a conversation, okay? But we can also look at the level of an account, and this is something that Anthropic did recently. What they do is they call it hierarchical summarization. So what Anthropic is doing is that they take individual user chats and they summarize them. And then what they do is they create summaries of the summaries. And then they look for patterns across time. And doing it, this level of abstraction is what basically helps them to detect these sort of more subtle, long-term patterns of intent that develop over time, that you miss in the individual message. Because oftentimes in an individual message or in the initial message, the user isn't clear about their intent, whether on purpose or not. So let's put it all together. This is our safety recipe at NVIDIA. This is what we do before we put out any model. We have open source models, our Nemotron series, and so before we publish any model, we go through this recipe. This recipe is also available. There's a blog post about it. You can see a blueprint. You can download the blueprint. You can deploy it yourself. But let's just walk through it. So notice, so here's a developer, okay? Our developer has developed a model, or they're using an open model. Now, the first thing that we want to do is we want to do sort of the evaluation, the vulnerability testing in the beginning. And so we have our set of content safety and security data sets. Many of them are open source. We have a framework called NEMO Framework Eval, and so we can take the data sets, we use LLM as a judge, and we also have Garrick, all right? And so we run all of these, so we look at the data sets, we have LLM as a judge, we have Garrick, and we end up with this model safety and security report that kind of says, okay, this is where you're at. This is how good you are, or where you lack. Let's say that we did great, and we meet all the requirements. Perfect. So now we can deploy the model, we can even NIMify it, wrap it as a NIM, accelerate it for our hardware, and deploy it. However, note that we talk in layers of security. So it's not enough that we did this, we still, even on models that we've deemed secure, we put guardrails. Okay, so we have our content safety NIM, or whatever NIM we choose, as guardrails, and that's before it hits the end user. However, we did the whole evaluation, and we see that we don't meet all the requirements. So now we enter post-training. In post-training, we use reinforcement learning, and we take our data sets, and we sort of go through an iterative cycle to ensure that we've managed to post-train our model to make it safer or more secure. After that, it goes back up to be evaluated, and either it gets the report, it either passes or it doesn't, and this is this iterative cycle. Okay, and this is for every deployment, every time that we put a model out into the world. So like I said, we evaluate, we post-train, we deploy, and we run. So I'll wrap up with this. This is a quote from Jensen recently, and he basically, Jensen Huang, our CEO, he basically said that the IT department of every company is going to be the HR department of AI agents in the future. That is not to say that the agents are coming to take our jobs. It's to say, basically, that we need to understand that these agents are going to be everywhere, and we're going to be using them. And we can't, and the way that I choose to interpret this is that we can't wait until they're everywhere, until we use them, and it's amazing, and we're all super productive, to then realize that we need to think about security and think about safety and how we put it all together. We need to start now in the design, in the planning, and start to sort of understand that this is going to be a really exciting time to be, both for the users and for productivity and for creativity, but also for security. And if you're interested, we're offering courses for free. There's an adversarial machine learning course. These courses usually apparently cost up to $90. And so with this QR code, you can get them for free. Thanks.